I got broads in Atlanta, just to lean the family. Credit cards in the scammers, hitting the licks in the van. Legacies, family, wait and see, look like a panda. Going out like a Montana. Honey killers on it.
Newton's first law of motion, referred to sometimes as the law of inertia, states an object at rest stays at rest, and an object in motion stays in motion unless an unbalanced force is present. When the ball is flung, it stays in motion. The reason it stops is because the other lacrosse head is in its way, which is the unbalanced force. The lacrosse ball would stay in rest in the lacrosse head, however, it goes back in motion when the flinging action is commenced, which is the unbalanced force. The second law of motion states the acceleration of an object as produced by a net force is dependent on mass and acceleration. So to demonstrate this, we had Viraj hit two balls with approximately the same amount of force. The first ball had more mass, meaning less acceleration. As seen, the first ball will not travel as far as the second one. The second ball had less mass, meaning more acceleration. The second ball will travel further than the first ball.
Newton's third law of motion states that for every action, there's an opposite and equal reaction. So to represent this, there was only one thing we could really do, and that was jumping on a trampoline. So when I jump on the trampoline, the action is jumping on the trampoline. However, the reaction is being propelled into the air by jumping onto the trampoline. So when a force is exerted onto the trampoline, that is the action, and the reaction is the trampoline exerting this force back at you and therefore propelling you into the air. That is what causes one to go up and down when they're on the trampoline. This is evident of Newton's third law, which states for every action, there is an opposite and equal reaction.
Speed is the rate at which an object covers distance or at the rate which something is able to move. So to demonstrate speed, we have decided to use an electric longboard that goes 5 miles per hour up the hill and 5 miles per hour down the hill. Basically, this means if the board was to travel for an hour, it will cover 5 miles.
Friction is the resistance that one surface or object encounters when moving over another surface or object. To test friction in our project, we decided to use the same ball and roll it over two different surfaces. The first surface was the road. The road was mostly smooth, and as a result, there was little friction and overall resistance. However, when we tested the ball on grass, the grass surface was much less smooth compared to the road, and as a result, there was more friction and overall resistance. Due to this, the ball came to a stop much quicker when in comparison to the road. Gravity is the force that attracts a body toward the center of Earth or to any other physical body or surface for that matter. So for our project, we decided to represent gravity using a piece of ice. So to do this, we froze a piece of ice and put it in a container. Then we decided to release it from a window. Due to Earth's such massive size, it had a strong gravitational pull. As a result, the piece of ice was pulled down toward the center of Earth, or in this case to the ground, which resulted in it shattering.
In this demonstration, we also found a three-step energy conversion. When the ice falls, it goes from gravitational potential energy to kinetic energy to sound energy plus thermal energy. Velocity is a rate at which someone or something is able to move or operate, but is different from speed because it also includes direction. In this example, the car is traveling at a speed of 5 miles an hour, but the velocity is 5 miles an hour east. In this scenario, the car is traveling at the same speed, but the velocity changes because it is traveling 5 miles an hour west.